Abhishek Misal welcome you to this comprehensive lecture on differential amplifier. Differential amplifier is a building block of operational amplifier, making it essential to grasp their operation thoroughly. In this lecture, we will discuss the differential amplifier, examine their mathematical expression, various input mode and the practical application of this versatile device. In this lecture, we will discuss the basic of differential amplifier. Differential amplifier is amplify the voltage difference between two input signal while suppressing common mode signal. The output voltage V out is proportional to the voltage difference between the input scaled by amplifier's gain. The differential amplifier is discussed about the differential amplifier, which is the basic building block of the operational amplifier. That is why it is very important to first understand the differential amplifier, so that in our next video we can understand the working of operational amplifier. So, let us first look at the differential amplifier, also name as the name suggests that it is a differential amplifier. It means that it consists of two input V 1 and V 2 and output is V 0 will equal to the voltage. Let us say V 2 minus V 1, we using need to minus V 1 because of the difference between the two input is multiplied by this capital A, which is nothing but gain. It means that whenever our output V 0 is equal to V 2 minus V 1 or V 1 minus V 2. This is not the point. The point is that it is the difference between the two input multiplied by the gain, that is capital A. If the input multiplied by the gain, it means that it is an amplifier, and this is what the special amplifier. Basic amplifier signal and that particular input signal, it is in a difference. A differential amplifier schematically consists of the following component and connection. First, transistor, usually 2. In the diagram you will see two transistor often represented as NPN or PNP transistor. These transistors serve as amplifying element. Input terminal, there are two input terminal labeled V 1 and V 2. These are where you connect your input signal V 1 is often connected to the base or gate of one transistor and V 2 is connected to other transistor base or gate. Emitter or source resistor, each transistor typically has an emitter for bipolar transistor, or if we are using the FET transistor, that is source. Resistors are connected to it. These resistors provide stability and control the current through the transistor. Collector or drain load resistor, connected to the collector in case of bipolar transistor and drain in case of FET transistor. These resistors act as the load for the amplifier. Output terminal, the output is taken from the junction point of the collector or drain load resistor. Power supply connection, there will be connection for the power supply, often labeled VCC and ground. These connections provide the necessary biasing and voltage level for the transistor to operate. Feedback component, it is optional if we can use or not, it depends on you. Depending on the configuration and purpose of differential amplifier, you might also see feedback component like capacitor or resistor for fine tuning the amplifier's characteristic. Common mode rejection ratio, common to improve common mode rejection, differential amplifier may include component like capacitor or additional resistor in the input path. The schematic diagram visually represent how the transistors are interconnected rejected and how the input signal are applied to amplify the voltage difference between V1 and V2 while rejecting common mode signal. Please note that the exact configuration and component value may vary depending on the specific design and requirement of the differential amplifier. Schematic can look like different amplifier types and technology like BJT, a MOSFET or integrated circuit based differential amplifier. Two transistor T1 and T2 and this T1 and T2 it is coupled with RC resistor. Now, the explanation of this diagram is here. We always use this term direct couple. It indicates us that this whole circuitry, that these two transistors are directly connected with the BC portion. With the help of two resistors, these two resistors are directly connected to each other. We have two transistors, it means that we are applied two inputs and that will show in the diagram. This is our V1 and this is V2. So, that the internal circuit of this block diagram, this V1 is applied at T1, let us say applying VCC, the terminal circuitry of this block diagram is V1. V1 is applying at T1 and V2 is applying at T2. This is called VCC plus and minus. This is the DC input. So, whatever operation is performed inside the circuit, we are actually replace it by this block diagram. Every time whenever we are interested in drawing differential amplifier, we will use this block diagram, and the negative terminal we are getting that V0, it is always equal to multiplication of this capital voltage V0. Whatever output we are getting, that is V0. It is always equal to the multiplication of this capital A, that is gain, and the difference between the inputs given V1 minus V2 or V2 minus V1, as we have two inputs at element of the open. So, whenever we using this term in this particular topic is that how we can apply the input, how many way we can apply the input, that is the first look of the applying the input, and this is called the mode of amplifier. This is V1, this is V2. So, this is a minus plus. We know that our output is equal to, in this case we are assuming that this negative terminal is given and this positive terminal is again not equal to V minus V2. We are V2 minus V1, a purpose that this mode input that we want our equally, but they are not in phase, that is they are out of the phase. What we can say that we want us actually equal to minus of V2. So, that I can say that even so V naught is equal to a times of 2 given. So, whenever input is in such a form that V1 and V2 are equal in magnitude is equal, but they are out each other. This kind of mode or such a kind of mode of input is called as the mode input. That is discuss the second type of input state. When we are using this term common mode input, it means that V1 is equal to V2. So, what we will get into input is 0. Same signal common mode. In the common mode input is basically used for rejecting the unwanted signal, and it is very important common mode rejection ratio. We will again discuss this point, that is how it is useful in. Now, V0 is equal to a time of V1 minus V2. Now, in this case of a signal and get input mode, what we can do that if we say let us V2 is equal to 0, we are actually grounding this V2. If we say if this way to it is ground and we are applying input, and even so what we are doing, what we are applying the input only at a single terminal, and this second terminal will be 0. So, such a kind of input mode is called as single input and single input mode. The differential amplifier output and how it's very different way. We can apply the input at the block diagram of differential amplifier. First one was differential mode input, second one was common mode input, and the third one was single mode input. The differential amplifier is component in electronic circuit, primarily function as a voltage amplifier, emphasizing its role in amplifying small signal. It is particularly well suited for application where signal precision is must. Unlike current or power amplifier, which emphasize different aspect of signal processing, the different amplifier excel at amplifying voltage differential. Differential amplifier are engineered with two input terminal V1 and V2, each serving a specific purpose in amplification process. These input terminal are interconnected with at least two transistors carefully matched to ensure they possess early identical characteristic. The symmetry in transistor characteristic is essential to maintain consistent and reliable amplification. Additionally, the differential amplifier connected the two terminal of V01 and V02 designed to deliver amplify the signal. These output terminal mirror the dual nature of amplifiers input, offering versatility in signal processing application. The collector resistance, often denoted as RC1 and RC2, are deliberately maintained at equal value. This equality in collector resistance ensure that both transistors experience similar operation condition, enhancing the amplifier's overall performance. The differential amplifiers symmetrically configuration, precision, voltage amplification, capability and balance design make it a cornerstone in electronic system, demanding accurate signal processing. It prominence in a various application including instrumentation, audio amplification and communication system, underscore its significance in modern electronics. The application and output option for a differential amplifier offer flexibility to accommodate differential amplifier in various signal processing need. Here we discuss the way significant can be applied and extracted from a differential amplifier input signal application, single ended input. The arrangement of the single ended input is in this mode the input signal is applied to one of the transistor while the other input is connected to ground or a fixed reference point. This configuration is useful when you have to single input signal and want to amplify it differentially. Double ended input. The arrangement of double ended input is shown below. In this, the double ended input mode signal are applied to both input terminal of the differential amplifier. This arrangement is employed when there are two distinct input signal and you need to amplify the voltage difference between them. Single ended output. The arrangement of single ended output is here. The output signal is extracted from one of the output terminal while the other output terminal is typically grounded. This setup is chosen when you require a single ended output, often used in application where only one polarity of the signal matter. Double ended output. The arrangement of double ended output mode, the output signal is taken from the voltage difference between two terminals, typically between the collector of transistor T1 and T2. This arrangement is advantageous when you need both polarity of amplified signal. It is worth nothing that operational amplifier, which are commonly used in various electronic circuits, often feature a double ended inputs and single ended output configuration by default. Op-amp are versatile devices that can be configured for a wide range of signal processing tasks, making them in electronics design. Their inherent characteristic make them well suited for many applications, but it is essential to choose the right amplifier configuration to match the specific need of a given circuit. Operation of a differential amplifier. Since differential amplifier and op-amp both have a single ended output and double ended input, so we discuss the operation of a single ended output and double ended input device. Single input application. Suppose we have a differential amplifier with two input terminal, input 1 connected to the base of transistor T1 and input 2 is grounded. Output option for T1 collector configuration. The output T1 can be taken as it is collector, which result in T1 operating in a common emitter configuration. In this case, the output signal will be inverted and amplify emitter configuration. Alternative, the output T1 can be taken at its emitter, causing T1 to function in a common collector configuration. Here, the output signal will be non-inverted and of the same magnitude as input signal. Input for T2, if you choose to take the output of T1 at its emitter, this output become the input signal. For transistor T2, in this scenario T2 operates in a common base CB configuration. Output option for T2 collector configuration. The output T2 which function in a common base configuration can be obtained at its collector. This output will also be final output of differential amplifier. The output signal will be non-inverted and amplify. The summary of outputs: inverted and amplify outputs at output 1 or terminal to T1, non-inverted and amplify output 2, that is on terminal T2. Understanding and inverting and non-inverting inputs. To distinguish between the inputs, consider the following. If the input signal applied to a terminal result in an output with the opposite polarity, that input terminal is referred to as the inverting input. Conversely, if the output has same polarity at the input, the terminal is known as non-inverting input, that is called DC analysis. A differential amplifier typically consists of two transistors, namely a NPN and PNP transistor connected in a differential pair configuration. These transistors are often referred as Q1 and Q2. The differential amplifier also consists of resistor, biasing component and power supply. The analyze the DC behavior of differential amplifier, we need consider the biasing condition. One commonly used biasing arrangement is active load biasing. In this configuration, a current source connected to two diode connected transistor provides the biasing of differential pair. Let us assume that Q1 is the NPN transistor and Q2 is the PNP transistor. The emitter terminal of Q1 and Q2 are connected together and bias at a fixed reference voltage, that is called V bias. The base terminal of the transistor receive the two input voltage, that is V in 1 and V in 2. To start the analysis, we need to determine the operating point or bias point of differential amplifier. This involves finding the voltage and current. Firstly, we apply Kirchhoff's law to analyze the current, assuming a small voltage drop across base emitter junction of transistor. We can approximate the base current IB is 0. Therefore, all the current flowing through biasing resistor connected to base terminal comes from the current source. We calculate the voltage at the emitter of Q1 and Q2. Since both emitter are connected, they should be ideally set at the same voltage. This voltage is determined by the V bias and the voltage drop across the diode connected resistor. Once we have the emitter voltage, we can calculate the collector current IC1 and IC2 using transistor mode and equation. These current are equal to the emitter current. Last, using the collector current and the load resistance value, we can determine the voltage at collector terminal of transistor. The difference between the voltage represent and amplify output voltage. It is important to note that due to the biasing arrangement, the differential amplifier operates in the active region of the transistor, allowing of their amplification of input voltage difference. In conclusion, the DC analysis of a differential amplifier involve determining the operation point, which include calculating the voltage and current within the circuit. This analysis aids in understanding the behavior of amplifier under constant or direct current condition. The operating point ICQ and VCEQ for differential amplifier DC equivalent circuit is drawn by reducing the input voltage V in 1 and V in 2 to 0 shown in the figure. Applying KVL to the base emitter loop of the resistor. The following equation show the actual calculation of this. Applying KVL to the base emitter loop of the transistor Q1, R input, I base current plus V base emitter voltage plus 2 emitter current and resistance emitter resistance is equal to voltage apply in emitter voltage, but I is the ratio of IC upon B DC and IE is equal to IC. Since VB is 0.7 for silicon and 0.3 volt for germanium. Generally, R input is equal to the 2R, because beta DC is very high. We can see that emitter current of transistor Q1 and Q2 are independent of collector resistance RC. The emitter voltage of Q1 is approximately equal to VB. If the voltage drop across R input is negligible, the voltage at collector terminal VC is given by VC equal to VCC minus I collector current into RC. The collector to emitter voltage VC is VCE equal to VC minus VE. From the two equation of BCEQ and ICEQ can be determined, this DC analysis is applicable for all type of differential amplifier. Comparison with operational amplifier. Both differential amplifier and op-amp possess a double ended input and single ended output configuration by default. Input option output 2 is grounded and output 1 is used. If output 2 is grounded and the differential amplifier's output is taken from output, you can apply the input signal to either input 1 or either input 2. The output signal will vary based on the input applied. When the input is applied T1, output 1 will provide a inverted and amplified output. When the input is applied to T2, output 1 will be provide a non-inverted amplified output. Understanding this input and output configuration is essential when working the differential amplifier, as they offer flexibility in signal processing for various applications. By leveraging these characteristics, engineering can design circuit their specific need, making differential amplifier valuable component of electronics system. AC analysis. AC analysis of a differential amplifier focus on understanding its behavior in response to small signal AC input signal. This analysis help us determine important parameters such as voltage gain, input impedance, output impedance and frequency response. Here a step by step explanation of AC analysis for differential amplifier. The first step is a small signal model. To perform AC analysis, we first create a small signal model of the differential amplifier. This involves replacing all DC sources such as DC biasing voltage or current with ground reference and consider only the AC variation around the DC operating point. Differential mode analysis. AC analysis typically focus on differential mode operation, where a small AC signal is applied differentially to the two input terminal V1 and V2. We consider the effect of the AC input signal on the transistor and the resulting AC output signal. A small signal equivalent circuit. In a small signal model, each transistor is represented as a small signal equivalent circuit. For bipolar junction transistor, this often include the transistors hybrid pi model, while for field effect transistor it include small signal model like transconductance model. The AC analysis include the transistor parameter like transconductance Gm and output conductance G0. AC voltage gain. Calculate the AC voltage gain of the differential amplifier. AD represent how the AC output voltage varies in response to AC input voltage. Is AD is equal to the ratio of output voltage upon input voltage. Common mode analysis. It is optional In some cases we can analyze this, otherwise it is not required. In some cases it may be essential to analyze the common mode operation, where signal are applied simultaneously to both input terminal. This is especially important for evaluating common mode rejection capability. Input impedance: calculate the input impedance of differential amplifier. Input impedance represent the impedance seen by the AC signal source at the input terminal. The input impedance is typically high, making the amplifier compatible with various signal sources. Output impedance: determine the output impedance of the amplifier. Output impedance represent the impedance at the output terminal. A low output impedance allows the amplifier to drive subsequent stage or load effectively. Frequency response: assess the frequency response of amplifier. This involves analysis how the amplifier's gain and phase shift vary with frequency. Bode plot or frequency response graph are often used to visualize this information. Bode plot or frequency response graph are often used to visualize this information. The next is bandwidth calculation. Calculate the bandwidth of differential amplifier, which is the range of frequencies over which it operates effectively. The bandwidth is typically determined by the transistor's parameter and the coupling capacitor used in the circuit. Stability analysis: ensure that the amplifier remain stable across its operating frequency range. This involves assessing factors such as a phase margin and loop gain. The noise analysis: for high precision application, noise analysis may be performed to evaluate the amplifier noise characteristic and signal to noise ratio. The AC equivalent circuit of the single input unbalanced output differential amplifier with T equivalent model is shown in figure, and the analysis of this AC circuit will be shown in the slide. You can see the mathematical equation and understand the analysis process. And thank you for watching this video.